Next one is bivariate analysis. That means analyzing two variables in terms of pre-post analysis, or in terms of right-left analysis, or in terms of ratios. We will do bivariate analysis. So first imagine we want to do pre-elbow flexion versus post-elbow flexion, whether it is improved or not, how to know. Okay, so this is called t-test. So this t-test affects so it is not here, so I will try here t-test in alcohol, and I go to the T, or just I will see the what I will get the answer now. It's getting ABS again, FX. I think alt is there already. So go down, not S T. Can you see T test? Okay, so go to T test. So it will ask array 1. What is array 1? So this is K2 to K7. That is array 1. Okay. This is pre-elbow flexion. Now I want to check this with the post-elbow flexion. So which is M2 to no. Okay, wait. Pre is K2 to K7. Now go to array 2. Then this M2 to M7. Now tails, you can read here. Tail 1 means it is all the sample is deviated to one side of the bell-shaped curve. That is called skewed distribution. Tail 2 means the sample is divided to two tails, which indicates normal distribution. So imagine you have two tail, then you have type. Test 1 is for pre to post. Okay. Test 2 is for two different samples, but they are equal. Test 3 is for two different samples, but they are unequal. That's what is written there. Yes?
No. 1 and 2.
1 is pre to post.
No.
What is written?
2 equal. 2 test, it's equal.
Equal.
Yes.
What is 2?
2 unequal.
2 unequal. What is 3?
I don't know.
No. So this is pre to post. This is 2 equal for 2. This is 2 unequal, 3.
Okay.
Okay. So now we want to do pre to post. So you put 1. Okay. Now you got a sample of this is value is called as p value. So the p value, if it is less than 0.05, then it is significant. That means there is a significant difference between pre values versus post values. So now the p value is how much? 0.01, which is less than 0.05. So that means there is a significant difference between pre-elbow flexion versus post-elbow flexion, which you can see this from the mean also. See, mean pre is 65 of elbow flexion. Mean post is 93 for elbow flexion. That means there is approximately 25 to 30 degrees of improvement in range of motion, which is statistically also significant by the p value. Okay. Now next thing is correlation. This you test by Pearson. So again, what you want to correlate? So maybe we want to correlate with the elbow flexion with elbow extension, range of motion deficits. For example, elbow flexion is increasing deficit, whether elbow extension also is increasing deficit or not. We want to correlate. So go to again FX, go for Pearson. Okay, Pearson. So you have Pearson here. Take it. Now which one you want to compare? We want to compare with the pre-flexion with the pre-extension and pre-flexion array to pre-extension. Is there any relation between flexion to extension? So what it came? 0. 0 means no correlation. Okay, or we'll see with pre versus post what will happen. So now instead of this, instead of pre, I will put post. Okay, see the correlation? That means 0.68. That is the correlation between pre versus post. So how to tell about this one? So now if you have values from 0 to 0.25, okay, then there is no correlation. Okay, if you have value from 0.26 to 0.50, then it is mild correlation. If it is 0.51 to 0.75, it is moderate correlation. If it is 0.76 to 0.90, it is good correlation. Anything is greater than 0.90, it is excellent correlation. So now what is the value? 0.68. That means this is between 0.51 to 0.75. That means it has moderate correlation. Pre versus post elbow flexion is correlated moderately. So this is bivariate analysis in Excel.